solve another problem based on work done. So, this is the problem, example 4.2 given in your book. Let me read the problem, listen carefully. An object of mass 2 kg falls from a height of 5 meters to the ground. What is the work done by the gravitational force on the object? So, when the problem is given, we should understand the parameters given in the problem, then only we should go for solving. An object of mass 2 kg. Now, what is happening to the 2 kg? It is falling from a height of 5 meters. So, now if I have to diagrammatically represent, then I would say, so the object is here and the mass of the object is given, which is 2 kg, and it is falling from a height of 5 meters. So, it is falling through 5 meters. Suppose this is the ground, it is reaching the ground. So, it is falling from this, and finally, it should come and rest on the ground. This will be the initial position and this should be the final position. So, now let us read the problem again. So, it falls, and what is asked is the work done by the gravitational force on the object. So, now what is the force? Gravitational force, because it is falling under the influence of gravity. And let us recollect our formula. Work done is equal to F cos theta. Now, carefully see what kind of a force is given. Gravitational force. So, gravitational force is a constant force. And so, this is the case of a work done by the constant force. And therefore, F cos theta is taken out, integral Ri to Rf dr. This would be the appropriate formula. So, let me just solve this. W work done is equal to F cos theta. So, this is integration Ri to Rf dr. So, I can write it as integration. So, when I integrate, it is R between the limits Ri to Rf, which would be written as Rf minus Ri. So, I have applied this formula to the particular case. Now, what are the parameters? I want F, I want theta, and I want the distance between the initial and the final, which is the displacement. Now, check, are they all given in the problem? Force, what type of a force? Gravitational force. So, what is the expression for gravitational force? The gravitational force is mg. So, mass, is it given? Yes, mass is given. And is g given? Yes, g is given. And therefore, now I have F. And what about theta? So, I need to know theta to calculate cos theta. So, what is theta? Theta is the angle between the direction of the force and the direction of displacement. Now, let us see this diagram. How the fall is from this height to the ground. So, this is the direction in which the object is moving. And what is the direction of gravity? Mg. Mg will also act on this object in this direction. So, the direction of fall is from this place to this, which is this, and the direction of the force is also, so both are in the same direction. So, what is theta? Theta would be 0. So, theta in this particular case is equal to 0 degrees, and therefore, what is cos theta? Cos theta is equal to 1. And what is Rf minus Ri? That is your displacement, and already it is given as 5 meters. So, now I know I have all the parameters I need to calculate the work done. So, let us substitute in the formula. So, W is equal to mg, F is mg. So, what is m given? 2 kg. What is g? G is also given here, which is 10 meter per second square. So, 10 mg into cos theta, which is 1. So, cos theta is 1, And what about your displacement? R of minus Ri already given as 5 meters, and that's all, 5 meters. So, what is this? 100 joules. So, do not forget to put the unit as joule, 100 joule. So, here we have applied this formula, taken the constant force out, integrated. So, and this is how you should solve the problem when such parameters are given. So, here we should note the force is the gravitational force and the direction of the force is downward, and movement of the body or the displacement is also downward, and that is how we identified cos theta to be 1. So, these are all small things which you should infer from the problem that is given, so that the concept is correctly applied to simple equation.